This lesson is going to be done in two parts. We've analyzed conditional statements. We're going to write definitions as conditional statements. First off, what is a conditional statement? Conditional statement is a logical statement that has two parts. It has a hypothesis and a conclusion. If we write a conditional statement in the if-then form, the if part contains the hypothesis, the then part contains the conclusion. So for example, if it is raining, then there are clouds in the sky. It is raining is the hypothesis. I'll abbreviate. And there are clouds in the sky is the conclusion. So keep in mind that it does not include the word if and does not include the word then. So we're going to rewrite a conditional statement in if-then form. Then it tells us that we need to identify the hypothesis and conclusion. As you can see, it's single underline for the hypothesis, double for the conclusion. And just a little note, if you look at this statement, we can't really just write if all birds then have feathers. We're going to need to add some words. So we have to add a few words here. So if an animal is a bird, and I'm okay with using pronouns, then it has feathers. So we underline single the hypothesis and double underline the conclusion. So the next example, two angles are supplementary if they are a linear pair. We take note that the word if is already there, so we're just going to write if two angles, and rather than using the pronoun they, I'm going to use what it represents. If two angles are a linear pair, then I'll use my pronoun here. They are supplementary. Underline the hypothesis with a single line. Double underline the conclusion. Again, the words if and then are not included in that hypothesis and conclusion. Okay, turn the page and you have 4 to try. In the second word, in the second example, the word because is like the word if. Okay, check your answers with those that I wrote. They don't have to be exactly the same, but they should be close in the same meaning. Okay, negation. When we negate a statement, we are writing that it's the opposite. The key word for negation is not. So if the statement is the ball is red, the opposite or the negation of that is the ball is not red. The cat is not black. The not is already there. The not is already a part, so the opposite of that would be to take the not out. So the cat is black. Conditional statements or if-then statements can be naturally true or false. To show that a conditional statement is true, you have to prove that it's true every time. The hypothesis is true every time. To show a conditional statement is false, you only have to have one counterexample. Okay? We also have a converse of a conditional statement. Converse, think of sneakers, walking. All we do is flip or exchange the hypothesis and conclusion. The inverse is when we negate both the hypothesis and conclusion. And a contrapositive is when we flip and negate both the hypothesis and conclusions. So I know that sounds like a lot. It will make more sense when we do a few examples. Okay, this is an example showing you a conditional statement. If the measure of angle A equals 99 degrees, then the angle A is obtuse. Then it's showing you the converse where you flip the if and then. The inverse where you take the original conditional statement and negate it. And then the contrapositive where you do the converse and the inverse. You also indicate whether they are true or false statements. So here's our statement that we're going to try. Guitar players are musicians. Well, let's write that as a conditional statement first. Conditional statement is your, sorry, I keep forgetting about the opaque here. Conditional statement is that if-then. So I'm just going to add the words if you are a guitar player, then you are a musician. And would we agree that that's true? Hope so. So the converse is when you flip. So now I'm going to put you are a musician after the if. And the you are a guitar player after the then. So are all musicians guitar players? No. So that would be false. The inverse refers to the original condition, and that's negating. So that's adding the not or taking the not out. And you have to put it in both the if and the then part. So if you are not a guitar player, then you are not a musician. And hopefully you would agree that that's also false. Just because you're not a guitar player doesn't mean you're not a musician. And the contrapositive is where we do both flip and negate. So think about negating the converse. So look at your converse statement and now negate that. If you are not a musician, then you are not a guitar player. And that would be true. If you're not a musician, you're certainly not a guitar player. Okay, I'm going to pause the video. I want you to try the next two examples. The if-then conditional is already given for you. And I do want to make note that, as you can tell, I copied and pasted, that this here is not guitar players are musicians. It's Great Danes are large dogs. But I already put the if-then conditional statement in there for you. And in number 6. Don't forget to decide whether they're true or false. So pause my video and try them on your own before you come back. Hopefully you paused the video and tried these yourself. I'm going to go ahead and write the solutions here for you. Remember, converse is flipping. I'm going to abbreviate Great Dane, GD. And is a Great Dane the only large dog? No, so this would be false. And this first conditional is true. If you have a Great Dane, then you have a large dog. Remember, inverse is negating. if a dog is not a Great Dane, then it's not a large dog. Well, this is also going along with the prior one. Just because you don't have a Great Dane doesn't mean you don't have a large dog. Could be a Newfoundland. And a contrapositive is both flipping and negating. So you have to recall what was on the prior page. So this would be taking the converse and negating it. If you don't have a large dog, then you don't have a Great Dane. That is true. In the next one, if a polygon is equilateral, then the polygon is regular. That's a false statement, because we know it has to be both equilateral and equiangular in order for it to be regular. Converse, you flip. If a polygon is regular, yes, it will be equilateral. Inverse, negating the conditional. If it's not equilateral, it cannot be regular, so that is true. And the contrapositive is negating the converse. So you flip and negate it, and you negate both parts. So can I have an equilateral polygon that's not regular? Yes, I can. So this statement is actually false. So if you take note, our conditional statements and our contrapositives were either both true or both false. So they went together. And the converse and the inverses of that conditional statement were both true or false. Okay? When we have pairs of statements like these, they are called equivalent statements.